You guys enjoying the convention so far? So today's topic is a little bit different. So we are going to talk about the schema translation, right? We heard a lot about the Unity catalog. Tomorrow you're going to hear a lot about Iceberg and this. But why we're talking about this one, right? I think there's a history about here. Last year, the biggest news in this conference is Databricks bought Tabular. Iceberg becomes the de facto of the open data format, right? But then, when you use this one, and you will find out, like we have a lot of catalog in the market. Unity catalog is one of them, and my friend here is the owner of Data Strato from Gravitino. That's another open source catalog as well. And now, it actually put all this metadata and inventory of objects in a single place. Now what do? You transform them. You move data around, and you move the data to where the compute is, right? Here's the problem. The data format and data type, they don't match with each other. Let's talk about that problem, right? Before I just prepare this presentation, I just struggled because there's so many we can talk about. You know, if you give me 2 hours, I can talk a lot about it, but we only have 20 minutes. So bear with me and see if there's something resonating with you. Number one, we're gonna face a lot of data type incompatibility issue. I'll give you some example and see whether you share the same pain. The second one is you deal with MongoDB, Cassandra, and all this NoSQL, right? Where's their schema? They don't have a schema. They're so flexible. But once you want to load them into your data lake, you want to get the performance. You want to scan billions of rows and the terabytes of data. You want that structured data, right? How do you bridge that gap, right? The third one is, anybody use protobuf here? Anybody is an Avro fan? Okay, you know what I'm talking about. One of union data type, such a pain, right? You love it in your RPC and API. When you go to data lake, they don't support it. Okay, how to handle that, right? Last but not least, you want the performance, you need index. You want to do sharding, you want to do partitioning, right? And you need to sort your data. It gives you 10 times acceleration. Where does that information get captured? Is that in catalog or it get lost, right? With that, we need to talk about the first problem, right? When we talk about the IDL, which stands for Interface Definition Language, right? The most popular one are RPC and Avro and the Thrift. These three are the most popular one, right? Back a decade ago, when we go to Hadoop, maybe Avro is the #1 popular data format, which is actually from the IDL definition, right? But now, do you guys remember, does Avro support timestamp? You use that a lot, right? But unfortunately, none of this IDL even support timestamp. That's one of the gaps. Think about the other data type, right? JSON is very popular. Does any of them support the JSON? It's just a string, right? Okay, these are some examples. We're talking about the gap of a data type system, right? And the other one, I came from Coinbase, right? So we're dealing with crypto. So one of the tricky part for crypto is you can have extremely large number or very precise decimal thing, which is up to like a 20, 22 decimal points. But then your integer part can be hundreds of the billions or even 26, 27 integer part. So if you want to capture this data in your data lake or Iceberg, the precision you need is typically like 40, 45 digits. And there's no support for that, right? That's another problem. And anybody has used unsigned integer, unsigned data for your tracking purpose? Unfortunately, Iceberg doesn't support it either. So how do we handle that? We need to do the conversion and we need to resolve this one, right? And the most interesting thing is about the overloaded column. Means one column has multiple different types in it. Depends on the other dimension or the category, the same column can have a different data type, right? This is very difficult to handle, but this is very popular in your API design. So now we need to handle how do we deal with this situation in the big data world, even with the help from Unity Catalog, right? So I'll give you a few more examples. These are some not so popular, but still quite useful data type, right? Let's start with maybe float 16. Float 16 actually means it's a reduced precision for float. And if you heard about something called FP8, FP16, FP4, these are very popular data type for AI. When you do inference, they try to use very low precision floating number to reduce the GPU memory consumption. But again, float 16 means it's a 2-byte float numeric. Unfortunately, this is very popular in AI, but it's not supported by the big data world, right? So this is one example. The other one is, think about enum, right? That is a very popular in multiple languages like Java and Avro and Protobuf. Unfortunately, Iceberg doesn't support it, Parquet doesn't support it, BigQuery doesn't support it, almost nobody supports it, right? So when we look at this problem, we are looking for a more comprehensive typing system. And this one gives you a little bit of idea to say who did a better job. So Apache Arrow actually have a better typing system compared with most of these popular ones, right? And that's why we actually trying to leverage Apache Arrow as the foundation baseline to build an even richer typing system on top of that, instead of using maybe Iceberg or even Spark SQL, because their types are quite limited. So the next one is what we're gonna talk about, the additional thing, which is not a data type, but the data layout, data organization. This is kind of a metadata that you also care, right? But then today's catalog, they typically only capture a portion of them. And when you move your data from one system to another, this information is lost. For example, your OLTP system have primary key, right? You have index. When you move that into data lake, all this is gone. How do you do your uniqueness validation? You just hand code some SQL to do the validation. But what if your catalog system or data typing system can capture that information and even flow that into your data lake, right? Even though the Iceberg doesn't support it, you can do your data validation using that metadata. That's some questions we want to pop up and let you think about it. Maybe we should ask the Unity Catalog to support it in the future. How about that, right? This is an example. The other one is like a partition, right? If you have ever worked with Oracle, Teradata, and even Postgres, you will see a lot of different partition strategy and mechanism to improve your query performance. But when you go to, Iceberg has its own partition, Delta has its own partition, and then you go to, other system like Presto has its own way. So everybody do a little bit, but that information were not fully compatible with each other. So that's another challenge we should be aware of, and we're going to talk about how to deal with that, right? So our goal is to say, if one system have a richer or additional metadata, we should try our best to flow that data to the next system so that we can make use of it, even though the other system do not provide the native support for certain feature, right? So this is not the exhausted list. This is just try to give everybody an idea what the problem space we're dealing with, right? You need to go back to say, do I need such feature for my use case? And I want to automate something. I want to take advantage of this additional metadata. So this is just give you some idea about that, all right? So now, let's talk about one of the thought process, how to address this. One is on the left, we called point-to-point. It's like you build a translation system, say Oracle to Iceberg, right? Then you build another one called MySQL to Delta. And then you build another one called Delta to Hoodie, right? And you can see we call that spaghetti. Hopefully that resonated with you better, right? It's a spaghetti approach to do this. But of course, we don't like it because it's really hard to maintain and you don't have enough leverage because every time you do this thing, it's point-to-point, right? So now on the right side, we have an alternative. This alternative is actually called hub and spoke. So in the center, we try to build something called superset. Means you have the most comprehensive typing system so that you do a more precise annotation about the data type and additional metadata information. And then when you try to do this translation from one to the other, you go through the center first so that everybody is trying to having a contract with the center typing system instead of doing direct connection to the source or the target. And we all see that with the big data and all the AI, the data's ecosystem are expanding rapidly, right? So we can anticipate that this picture on the right will easily double, has more components next year by this time. And then if we look at the left side, and I can't imagine how that picture will look like 12 months from now. That's why we're here to advocate for an open standard and open source approach on the right side to handle the translation among different systems, okay? And now, of course, any standard need to have a specification. I'm giving you a little bit like a very technical thing, right? This is probably not my favorite slides, but definitely something I can go very deep and spend a lot of time on it. So for the sake of time, we will talk about maybe two important things, right? The most tricky part is about three different data types we're going to talk about, right? The native data type is the easiest one. Every data catalog has it. The logic data type is the one currently is missing. If you have dealt with Avro and Parquet, you will see something called logical data type. But when you go to Unity Catalog and many other things, and that one is gone. They only have the native data type. So what is a logical data type? So please take a look at the sample on the right, right? You have something which is, it's a string. But the logic of the data type will tell you it's enum because you know it's a limited category or dictionary. So string is a much, I would say, coarser data type than enum. Enum is more specific, right? But again, I mentioned earlier, there's only one system in our example support enum out of a box. So that means everything else, they don't support this one. So that enum doesn't go to your catalog. But when you try to do the translation, for example, you want to do a validation of the enum because it should only have 12 distinct value. But if it's just random free from string, then you don't need to have this constraint, right? So how do you capture that? This one need to conform with the 12 distinct value for that column. You need to carry this logical data type forward, right? And of course, if you can also capture those 12 values in your schema translation and propagate it from one system to another, then you can do a lot with that. This is just one example to explain what is a logic type. Of course, there are more examples about how logic data type can be different from your native data type. The main reason is your native data type has limited support for certain things based on your decision. How many people were using Iceberg v2 before this week in your system, right? I'll just give you a funny example, right? Iceberg v2 only supported timestamp with a microsecond. You cannot have, timestamp with second. You cannot have a timestamp with millisecond, and you cannot have timestamp with nanosecond, right? Then you just see something called timestamp, but then you don't have that precision with it. That makes your data conversion very, very difficult. If you ever try to move that like a timestamp between Delta and Iceberg or Snowflake with Iceberg, you will have a lot of trouble because you never anticipated you will have a trouble there. So that is another example why capturing this logic data type can give you a lot of benefit if you want to automate this system when we try to move data around the from one system to another one, right? So that's one takeaway I really want to highlight to say logic data type is important, but we don't want to stop there. I want to talk a little bit about the semantic data type because this is called the AI Summit, right? So everything has something to do with AI. So what is AI is about? AI is about using agent to understand your data, generate a query, and harvest the insight of your data. And a lot of you guys heard about the semantic view, semantic layer, right? So we need to talk about what is a semantic type before we go there. For example, you have a column. It's called ID. What is that ID? Is that user ID, account ID, order ID? It's just a usual ID. Even when you look at the column of content, you still couldn't figure out what it is. That's why such semantic annotation or semantic type can give you a lot of information. So if you want to use AI to query this data, then you need to know whether this ID is a user ID or account ID. And how do we capture that data? Maybe you know that in your OLTP system because that is your customer data, right? But then when you ETL that data into your data lake, that kind of information, this is account data or customer data, or this is a wallet or something, that information can be lost unless you name your column called user ID. But in many situations, we just name them as ID, right? You guys see that a lot. How do I know this ID is what, right? We need that annotation. That's why this semantic type, even though it's optional in here, I want to spend like 2 minutes to talk about it. Because you want to build a better AI ecosystem, start leveraging, annotating, maintaining semantic type once you have a chance. Of course, we want to build a system so that this annotation doesn't stay just in one layer. We want them to flow all the way to your downstream because your AI BI will happen at a later time, right? Not happen at your ingestion time. How about that, right? Last but not least is you can see this one is a highly normalized data model. Like any nested structure need to be really flattened, right? You can see the hierarchies precisely, right? This is very different from the NoSQL world. NoSQL world is just giving you a blob, right? When you use a Hive was also a metadata, right? Meta store. The Hive way to capture this one is probably only 6 columns, right? Every nested thing is just a big blob thrown into you. Then if you want your AI agent to make more code generation out of this kind of table with nest structure, you need to tell the AI agent precisely how the hierarchy looks like. So they can actually extract the nested column, no matter it's a dictionary, it's an array, or it's just a simple tuple, or it's a JSON, right? So that part of a schema is also kind of missing from today's catalog system. That's why we want to talk to you, and let's come back and say, hey, Databricks, can we fix this thing, and let's support this typing system better, all right? Okay, so let's talk about how do we put this thing together and make use of it, okay? In addition to ask some of your coworkers to carefully documenting this, and I would think let's use the AI agent to figure out how to do this in the first place, right? You need to do a reverse engineering to understand the data content so that you can figure out all these things. You have to sample the data, and you also need to accumulate your findings. And the Databricks provides some very good functions to do schema discovery, okay? But it can be expensive to run. That's why we need to do this in the more incremental way. Otherwise, your schema discovery can be very expensive for you to operate, okay? So what we do here is we create something called Schemaster. So the internal product is actually called a Schemaster, right? That is trying to master your schema in the way that to solve the problem we just mentioned earlier. And a couple of things we've already talked about, all the problem statement. We will build this into a system and provide you with the a standard API so that no matter you're using Spark or Python or your microservice, you can tap into this schema translation system and you can accumulate your translation convention for your own company. This is not something we can standardize across the universe. That's why you need to kind of accumulate this kind of knowledge there, all right? And also, this can be used not only for ingestion. Let's say move your data from online to your data lake. But once you want to publish this data back to your AI system, typically you have your feature store, right? Your feature store is running in Redis, in DynamoDB, or something like that. They also have a different typing system than your data lake. You also need this translation back to do that, because otherwise you cannot match them easily. And one of the benefits is this can enable you to do a lot of data quality and matching in the same way, all right? So we're just right on time, so I'm hoping that you can have a little bit of takeaway from this one. This is not yet a product either from a Snowflake, Databricks, or anybody yet, but this can be added on top of this catalog system. If we focus on automating the translation, right? So the number one thing is we need a comprehensive typing system, okay? This is beyond the vendor boundary, right? If Databricks say, okay, Spark SQL is my standard, we need to say, okay, there's something bigger than that, right? The other one is nested data needed to be taken care of. Don't just, kick the can down the road and think, okay, we'll figure out it later. Figure it out as early as possible, right? The third one is, if you spend the effort to annotate the logical type and the semantic type, make sure you have a pipeline to propagate that all the way down. Otherwise, you cannot rip all the benefit, all right? And last but not least is, okay, semantic type. That is for your Gen AI practice. You're gonna benefit from that later, okay? And of course, we're looking for more and more companies and the people who feel the same pain and also passionate about solving this problem. This is the stage not for us to really to sell any product or show off any solution. We are here to looking for people who wants to solve this problem together. And thank you for your privilege of your time, and I'm open for some questions. All right, thank you.